Okay, this is the third try of the audio. This is the Southern California Robotic Society.
Okay.
Let me start over. This is the Robotic Society of Southern California February meeting. I am the current 2020, and today we are live streaming the meeting for the first time. I think everything is working. Yeah, we have audio. So we have a good show. We're going to start off with our one of our guest speakers, Alan Tim, which is going to give us a very nice tutorial on ROS. Ready?
All right, let's go ahead and get set up here. Yeah. Okay. All right, so the original game plan was to give you an enthralling discussion about gazebo simulation in ROS, but I ran into one snag. The gazebo simulator doesn't run on my laptop. Without that, it becomes a hand I can do kind of a thing. So we're going to put that off, and I changed the talk to talk about something else that I think is actually even cooler and more tangible, which is my little side project called ROSCore. So there's a couple of things that I'm going to do here. Let's plug in my laptop first. This will work. All right. All right, and
Oh, that's a time.
let's see. Is anyone monitoring right now? I think it's going to work better with lights up, just for the webcam. Let's see. So I'm going to be right. It's so embarrassing to watch later. This is so much easier when you watch someone else do this. All right, so just a quick recap of how I got to where I'm at. Everyone knows about the Raspberry Pi Zero and the Raspberry Pi Zero W. It's been out in various forms for 4 or 5 years now. It's just based on the Raspberry Pi 1. My guess is they had so much excess stock, they decided to make something smaller. And for years, I've been trying to figure out something that really made sense to use it with. There's lots of stuff where you could say, a Pi Zero would do. But I think this is the first project that I've seen where it actually uses it to its full extent in a way that it makes sense. So you're talking about a $10 device. You've got Wi-Fi and Bluetooth built in, 512 megabytes of RAM, micro SD for memory, runs Raspbian, runs the full Linux stack. And this is going to be, just quickly, this is for my COD project. This is the earlier prototype. A little bit of a lag right there. There's been a couple of different TODs. My first yellow one was the prototype. The final one, I'm not updating again. That's a final hardware design, and I'm not going to touch it because it's done, is the green one. And the, there's no show up. And the orange one is a prototype for a 3 degree of freedom guide. There's actually supposed to be 3 of them. One's done, one's almost done, and then the third one, which I'm calling Type S, I want to do a similar design but modeled after the Spot Mini. So this is the one I haven't started yet. It'll be another 3 degree of freedom leggy thing. I just have to figure out how to make it in a way that looks cool and is small. And that'll complete my trio of robots for ROSCore and for this platform. Everything that you see here for TOD will be released open source or already is. The 3D files are released on GrabCAD. The STL files are released on Thingiverse. And what's cool about that is that if you kind of like the direction that I was headed, but you think that I could do something better, which is absolutely true, you can grab the 3D files and make those edits yourself, no problem. The original Fusion 360 file is there. That's my modeler of choice. I also posted it in STEP and a few other formats. And so just catch up. There was an older wiring diagram for those of you who want to get into this. I will update this at some point. But really the electronics is pretty straightforward. It's even simpler than this. There's a Raspberry Pi Zero W you've got for the brains and the Wi-Fi, an ultrasonic sensor with a voltage divider on the return to get ultrasonic, to get ranges back. Camera, Raspberry Pi camera, and a 9-axis IMU. So a couple of fun things about this is I think all of us have done the ultrasonic sensor at some point. It's kind of a hello world for hardware. And on the Arduino, it's really straightforward. You kick off a pulse with a certain duration, and then you have a wait, and as soon as you get the echo back, you do some math, and bam, that's how many meters the echo is away from getting an echo. And on the Raspberry Pi, it actually kind of works the same way. The code is the same. You kick off a pulse, you wait, you measure the time for the echo, and you're fine. But there is one difference that means that occasionally it's not going to be quite as accurate, and that's because your Arduino is a single-thread, single-process computer doing exactly one thing, and your Raspberry Pi is a Linux computer that's multitasking, preemptively multitasking, which means you never have control over which task is running at which time, and the task switches happen very quickly, but there could be a time where you miss a pulse or it's late as your computer switches from one task to the other. So this is one of the, I wouldn't call it downsides, one of the realities of working with a preemptively multitasking operating system like Linux or Windows. And for those of you that are sensitive to that, there are other operating system alternatives that can provide certain soft or hard real-time guarantees about the processes you run and the turnaround time for switching back and forth between tasks. I'm not really as concerned about that, but if that is one of your passions, I would love to see this kind of solution migrated over to one of those platforms and to see if it solves more problems than it causes for you. For me, the only problem that it causes is that occasionally I'll get a wrong distance from the ultrasonic sensor. So let's go through the background a little bit more. For those of you who know, and it's not a fight and a championing, all of us seem to prefer a different type of a platform or operating system or framework to build robots. We've got, what are some of the other ones? That little box. There's RoboRoam. There's, what's the other?
Easy Robot.
Easy Robot is a popular one. I keep going back to ROS because it seems to solve more problems for me than it causes. But there is, as a framework, there's a lot of pieces to it, and it's a little bit harder to pick up. But just to recap, all ROS is a framework that allows you to build multiple applications that communicate with each other asynchronously over topics passing predefined messages. So if you're solving something simple enough where you can write one program with one thread and get it done, then Arduino is the way to go, absolutely. But once you start writing more complex things, like you need a process that analyzes the video imagery and identifies objects of interest, and you have a subprogram that you give navigation coordinates to when it walks over there. You start separating out your code into different tasks. Then a ROS type solution really fits better because it solves all those problems about communication and logging and tracing and feedback and all that stuff. ROS.org, you can download this for Windows and Linux. They recently moved to Discourse, which is a great place to hang out if you're working on a project or have questions. It's a loosely knit community of people who come at ROS from all different angles, but aside from people in the club, if you are working with ROS and have a problem, your step one should always be a Google search. Google's your friend. But then if you want to start a conversation, ROS Discourse is the way to go, the place to be.
So it's like a blog or something?
Yeah, kind of like a messaging board.
Okay.
Like a pretty good version of a messaging board. There's also a whole bunch of tutorials. This talk isn't going to be about how to use ROS specifically, but if there's interest, we can come back and do that. This is specifically about my ROS core solution and as an appliance, how you can leverage it in your own projects. And finally, for those of you who want to learn more about ROS, this book I think is 20 years old. 8 years old now. It's available for free online as a download on the web and PDF. This is a fantastic primer on ROS concepts if you feel like you need to really dig into it and learn how everything works. This is a cover-to-cover book. This isn't like a dictionary where you pick and choose. Read it from the preface all the way down to the index. I think I read through it 3 or 4 times when I first got started, and it's a great resource. So what have I done? So I'm going to go ahead and plug this guy in now. That's a really thick cable. So what I'm gonna boot him up, and I'm gonna show you what he looks like when he boots up. What I've done is I've given you an appliance. What you can do is you can download my image from my GitHub, load it onto a micro SD card, and boot it up. The entire boot process takes about 3 minutes, which isn't great if you're doing something for reals, but this is a toy, so it doesn't matter. And about 90 seconds of that is taken up with booting up into Linux. The processor on this isn't super fast, but it's fast enough. And the remaining 90 seconds are taken with automatically booting up all of the raw stuff. So the highlights are, and keep this up.
So you can plug it in as like a little computer and everything.
Exactly. So we'll talk a little bit more about this while he's booting up.
Wow.
So this is one of the things that I'm really excited about when it comes to this platform is that you can do a lot of really cool, awesome stuff in a very small space. So this is like a mini Raspberry Pi. You get Wi-Fi for free, you get processing for free, you get Python, a full Linux stack. And there was a previous version of this where I called the Raspberry Pi, where I stuck everything in the kitchen sink into the image. So you are running everything, the development environment, image classification on the Pi. And in theory, while that would have worked, it's not a good fit for it. So in my plan B, this guy boots up as a ROS appliance. All you have to do is burn it onto a card and boot it up. He comes up, the Wi-Fi comes up as an access point you can connect to. That's why I've got this super geeky antenna here. So as a second Wi-Fi, so I can connect directly to the robot. The robot doesn't have internet, doesn't even know what time it is. It's not its point, it's a ROS appliance. It boots up, it comes up with the main ROS master program, and then all you have to do is connect to it. I think we're about the minute mark right now.
Like it's booting up right now.
Mm-hmm.
Cool. It's a lot of stuff.
It's a standard Linux Raspberry.
And so as soon as we get a prompt, I'll bring up HTOP and we'll look at our timer and see how long it's going up. There should be about the 90-second mark. And so it's not fast. So what's funny about people is we always have things that we're passionate about, right? So for me, oddly enough, it's actually not making Todd work, but solving these kinds of problems, because that's something that hasn't been done before. As far as creating an OS that boots up faster than 90 seconds, I'll just deal with that, because that's not where my focus lies. But if any of you, if that's your passion, that's a problem you feel like you want to solve, there are actually people out there in the microcontroller space whose only job is to whittle down these Linux kernels to boot as fast as possible for embedded devices. So there are ways of approaching this to get it to boot up in, gosh, probably 30 seconds, 20 seconds, if that's what you'd like to solve. And if you do, please let me know, and I'll integrate the code back into ROS port. So I'm going to run a simple command called HTOP, which just shows you what processes we're running. Well, except this is the keyboard for my computer. This is the keyboard for the robot. A little embarrassing, but I do the same thing at work all the time. All right, so this is super, super tiny. So for those of you that can read it, you have a list of processes going top to bottom. It's sorted by CPU time. It's still in the process of booting up. So after the operating system boots up, it takes about 90 seconds to get all the ROS stuff started. So ROS starts automatically. It's starting up the camera and the ultrasonic sensor node and the temperature node and the IMU node. There's another one in there too. And so the top one right now, it actually takes it a good minute to get the camera node initialized. Part of the reason this takes a little bit longer than you'd expect is because a lot of this is written in Python, which is, again, isn't a bad thing. But Python has to be compiled. Again, not a bad thing on modern hardware, but when you're on a single core 1 GHz processor, the penalty for that is a little bit higher than on modern hardware. So if you're doing this on a Pi 4, for example, you would go from a cold start to running ROS in like 30 seconds, I think.
The Python is actually, you mean it's just-in-time compiled, basically, and then, but once it's all started, things do run reasonably well in real time for what your needs are, for the needs of the robot.
Oh, yeah, yeah. At any point, it's possible to optimize this to make them better or faster, but that's not where my passion is. I want to eventually get this thing to walk. Could you swap out portions of the ROS framework for faster versions? Absolutely. There are entire careers built around making these things boot and run faster. But for me, I just want to use the stuff out of the box so I can focus on some more of the fun stuff.
But I just meant that once everything is initialized, then the running of it is good. And it's just this delay at the beginning, and then once it's running, it's not overloaded. In other words, the processor is okay.
Yeah, exactly. Exactly. And so I just plug this in so you can see it. Without the keyboard and without the HDMI, you flip that power switch, it boots up the same way in the same amount of time. It's an appliance. So at that point, you have a fully functioning ROS system with nodes that communicate. You could load this image on a straight Raspberry Pi 0 to a Pi 4. Now, without the peripherals, it won't do anything very interesting. But there's still something I left in as kind of a hello world example for it. And one of those nodes is a temperature node. I left that in for two reasons. Reason number one, I didn't put a heatsink on it. You don't really need a heatsink, but I've also sandwiched it in between other components in a very small robot. So I wanted to keep tabs on how hot the processor was getting. Not only because you don't want to get too hot, but it is next to a LiPo battery, and they tend to behave badly when they're used. But also as a hello world example, this is a great way to get started on the other half of ROS development. When you get this thing booted up, if you can communicate and get the temperature back from your TOD, then you're ROSing. It's pretty cool. So I'm going to unplug him now. I'm going to leave him turned on, and I'll switch things back over to my laptop here.
So it's still booting up then?
Oh no, he's booted. Yeah. Yeah, the entire boot process is from cold start to ROS is fully loaded. It's about 3 minutes. Where was I going to go with that? There was one more thing I was going to. Oh, the GitHub. So, like all my stuff, I post everything online for free. My GitHub has a. This is the Raspberry Core. Oh yeah, this is the one that we're looking at today. It's fully featured. It works. You download it and plug it in, burn it, and everything will work. I'm also going to give you a list of everything that I put into it. Now, I'm not going to drain how this is constructed, because I think this is super interesting, but it makes for a really boring talk. So each one of these links will take you to some of the tools that I use to make this work. Where I grab the image from, where I grab ROS from, what packages are compiled into ROS. Another fun little fact. If you're going to do ROS on a Raspberry Pi, like a normal Raspberry Pi, you're not going to bother with this road. You'll get all of these things with my packaging if you do it. But if you use it through the official packages on Ubuntu Make, everything just installs and runs out of the box. So that's what it's designed for. It's also compiled for a version of the ARM processor called the ARM v7. So you have more extensions, a little bit faster, more stuff. The Raspberry Pi 1 and 0 is an ARM 6 core. So I can't use any of the compiled stuff. So what I actually had to do was take the source code files, follow their instructions exactly for how to compile from source. I compiled them on a Raspberry Pi 4, which takes less time than if I were trying to do it on a Pi. I think it took 30 minutes of compile time on the Pi 4. I think last time I was, what's the word where, sadistic or masochistic? The one where you're self-harm. I think it was about 4 hours last time I tried to do it on the Pi 0. So you can do it, it's just not practical. So once that's done, you take the image out, pare it down to a 4 gigabyte size, upload it, and then you can download and use it. Some of the cool tools are the Create AP. That's the tool that I'm using to use my Wi-Fi as an access point. And I'll show you in a second how once that's up, you can just log into it. There's a very cool IMU library called RTIMU-LIQ. This is a solved problem. The IMU, calibration, all this stuff, someone else way smarter than me has already written a library that does that. So on larger hardware, on Linux and computers, if you're using one of these older, super cheap, 6 or 9 axis IMUs, just use the library. Don't worry about anything. There are some ones that, additional libraries that will approximate that solution on Arduino class hardware. And This works perfectly except for one thing. There's a calibration program that I can kick off on the robot, and for whatever reason, the code will not accept keyboard input. So I can start the program, but I can't say start calibration routine. So I'm still working on that one. But once you do that, you log into the bot once, you have the calibration routine, just like your phone, you take it through a couple of things so it can calibrate between compass and everything else. And you're supposed to get more accurate IMU readings than without. Someone had already written a ROS library to interface with the PCA 9685, a 16-channel PWM driver. Now, technically, you can try to get PWM pulses off of the Raspberry Pi, but they're awful at it. Because remember, it's a preemptive operating system. And even though you can get close, there's nothing like having dedicated hardware to pick up pulses at will. So that's why I went with a small sideboard. I also included G5L0, and then there's a link to a way to automatically kick off all of the ROS programs when you boots up. So in every sense of the word, this is a ROS appliance. Really, all you have to do is burn it and boot it up, and then you just have to connect to it.
I'm sorry, that sideboard, that's seems like an important point. It's called the 9685. It's a
Yeah, so that's
daughter board.
Yeah, so that's the chip that you'll see as an Arduino and a Raspberry Pi hat. It's a 16-channel PWM driver. It's used, actually, most people use it for driving LED lights.
Is it a hat?
Is it a hat?
So it's available in a hat form. It'll plug directly into the Arduino or the Raspberry Pi. I'm using the one that you don't plug directly in. It's communicating over I2C. But you can pick these up for like $3.
It's a little board. Then you have separately just connected wired.
Yeah.
Okay.
Yeah.
So that's a little it's a PWM. It's a little microcontroller kind of. It's serving as a microcontroller.
Yeah, I got pictures here. There we go. Internally, the way it looks like on the inside.
That's the IMU, right?
Yeah. So here's underneath. So there's pathway type. There's a Raspberry Pi 0 on one side and the PCA board on the other. There's just enough room on the bottom for 16 plugs. Over here, you can't see it. Over here, there's just enough room for one buck-down converter.
Oh, you needed a buck down to go from 5. Was it drop down from 5 to 3, or?
So yeah, the 2S LiPo will kick out a peak voltage of about 7.4 volts, which is too much for, well, it's not too much for the Pi. There's a built-in LDO in the Pi that you can feed it whatever you want. I wanted to get the voltage as low as possible, and I initially had two. I had one buck down to power the Pi, which ended up being redundant because there was already an LDO on it. And the other one was to bring the servos down to 4 volts. Well, I kept making this guy smaller and smaller. By the time I was finished, there was just enough room for one board. So right now, the buck down feeds 5.1 or 5.2 volts to both the Raspberry Pi and the servos. So those of you who've done hardware work are probably thinking, oh my God, you are running your computer and your motors off of the same supply. And I was wondering the same thing, if it would work. Here's why I think I'm getting away with it. There's two reasons. Reason number one is my servos are so small that the amount of stuff they do to mess with the voltage line and ground doesn't appear to have an effect on the Raspberry Pi. There are larger motors. There's a filter capacitor that I can put on the board that would help mitigate that, but so far I haven't needed it. But the thing that I think is really saving me is it's called the C rating. So we talked before about LiPos and lead acid and how much power you can suck out of a battery at one time. So this battery has a rating of 20. So I believe that means if the label's accurate, which probably is not, is that I can instantaneously pull up to about 20 amps from the battery before the voltage starts to drop. Now, I'm not going anywhere near that. If I even approach that, that means I've shorted, so I'm using my built-in 2 amp fuse. Oh, we're all using fuses, right? To keep it from exploding. But I think because of those two reasons, this is why I've been able to go away with it. Because most of us who have built robots have done this on accident and couldn't figure out why the computer kept resetting or something. Yeah, Ron.
What are you using as your power supply?
So this guy uses a 1 amp QS 7.4 volt LiPo, a 2-cell LiPo. And crunching the numbers on it, it says
You
that
just plain straight from the batteries
so he
or a
plugs,
regulator.
well, my LiPo plugs into a battery management circuit to keep me from overdrawing it, because LiPos will behave very, very well as long as you don't overdraw it or overcharge it.
Okay.
So that guy's only job is to cut off the battery when it goes down to like, what is it, 7.2 or 7.1 volts or something. And then from there, it goes into a small buck-down converter, this little guy right here, which takes it from 7.4 to 5.2. And there's a fuse in there somewhere.
You put in the fuse just yourself in line.
Yeah. Yeah, so everything's hand-wired.
What was the rating on the fuse?
I think I'm using a 2 amp fuse.
2
I
amp,
couldn't
okay.
imagine something more than 2 amps.
So you just think about what the maximum you assume you're gonna have, and
Add like 50%, but yeah, you have to think of spike voltage versus, normal.
so you have to be, you have to think about, maybe that's kind of could be difficult if it's a
Yeah.
new project, right?
Yeah, and I'd much rather burn the fuse, and the fuse is literally soldered in between 2 wires, like
Oh.
literally fuse, wire, solder, and a little bit of wire. Yeah,
What you can do is, for your computer, is to use one of these little power supply modules.
power supply modules, what's that?
Well, a regulator,
That's pretty much what he's doing. He's using a
but it's a lower power regulator, because the
Yeah, I got this guy.
computer doesn't need but you have a stable voltage, and then the power can be fluctuating all over the place.
Buck
Yeah.
converter. I have one.
Yeah, exactly.
Next to my little one.
Yeah.
And the other thing that's probably saving me is that on the Raspberry Pi, there's a 3.3 volt regulator that feeds off of USB. So actually, I've got 2 things in the way, and really it would only adversely impact the Pi if I would go 3.3, and you'd have to have a short to do that. So far, I've gotten away with it. Yeah.
What's the current rating on your buck converter? The output, current rating.
Oh my gosh, that's a great question.
I mean, that's the key thing. It's not your battery.
Yeah.
Your key parameter is going to be the current rating coming out of the voltage.
On the middle of the Pi Zero, on the regular Pi, it's 300 milliamps for 3.3. But that means you get a whole lot for anything else.
Yeah, these are. Okay, I'll put current 3 amp now, so I should be fine. But that's another good point, when you're sizing out your components for your system, I can get away with this because everything's so small. I wouldn't be able to use this buck down to power standard size servos in a larger design, you have to take that into account. It's a very good point.
But it's very good for your computer.
Yes.
So this in other words, this helps prevent the spiking or whatever from the motors as well. Is that that point?
Well,
you're making?
this will give you 5.2 volts
very
steady
even.
over there within certain conditions. As long as
Less
your
than 3
input
amps,
voltage doesn't drop under 5.2,
of course.
and your total amperage draw doesn't exceed the power rating of the buck down or the battery. And the battery, you have to short it to get it. You've got
The
to
battery
transfer
goes up
it,
to
yeah.
many 20.
Whereas lead acid, it's, what are they at, 1.2 or a 2? They're a lot lower. So you can actually draw so much power so quickly from the lead acid that the voltage drops. But yeah, so far everything seems to work together, and I've been able to get away with it. All right, so I plugged in a second Wi-Fi dongle here. You don't have to. You could use the one built into your laptop, but I kind of like having internet as well as connectivity to COD. So I picked up one of these guys for like 12 bucks. I chose a big antenna because the built-in PCB antenna on the Pi Zero W is so tiny. I figured the largest antenna I had on this side would give me the best chance of communicating with it. Yeah.
That size antenna is rated for about 1,000 feet,
Okay.
whereas the others are 100.
Yeah, last time I took him through, I had over Garrett. I had him take Todd to different corners of the room to see if I could still get a signal from him. So in this environment, I was able to get pretty good throughput, even from opposite corners of the room. So this isn't like something used for a spy in a different house or a different city. But for stuff you want to do around a room in your house or in a different room, you should be okay. So far it's been working out pretty well. So I'm going to go over here in the drop-down, select Wi-Fi number 2, which is the Wi-Fi antenna I just plugged in. And I'll go ahead and click on Todd and hit connect. Oh, I'll show you. And after a second, it'll say connected but no internet, because Todd doesn't have internet, it's just an access point.
Just like the slam tap that we use.
Mhm. We'll let that connect. There are 2 other tools I'm going to walk through with you today. For those of you that aren't familiar, well, on the raw side, a lot of it is DOS prompts and scripts, a lot of typing. The first tool I'm going to show you is called PuTTY, if you're not familiar with it. PuTTY is a tool to connect remotely to other Linux or Unix computers. I don't remember why it's called PuTTY. The protocol is called SSH. And once you have that set up, you'll load this guy up. So my host address is always 192.168.12.1 because that's the way the access point is set up. And assuming that we are connected, so yeah, making that secure. Go ahead and connect to it. The first time you connect, it exchanges a key that it uses to verify or validate you are who you say you are. Okay, yes. And super secret login for my Raspberry Pi is Pi. And login for this, I think I changed the roster. Let's see. Okay.
So now you're talking to it.
So through SSH, I've logged into the robot, and now I'm running all of the code and everything on the robot. So you can run that htop command again, and there's a couple of things I'll point out. Once everything's booted, I'm usually around between 50 and 60% CPU utilization, so that means I have a little bit of headroom if I want to do something else.
So it's still booting?
Oh no, it's all booted. Yeah, it's all booted.
This is
It's
just all
locked
the stuff that's currently running.
Oh, this is what's going on.
Yeah, this is all this. Wow. So it's using 50% of the CPU just doing its servers, essentially. It's raw servering, right?
in. It's just Rawson. Yeah, let's make that a little bit bigger.
It's awaiting for connections, basically, right? Or for,
And something else I want to point out. So the program we're running right now is called htop. It's just a process monitor. It's one of 2 or 3 that is built into
some
Linux.
CPU.
Check this out. Just running the process monitor uses between 6 and 8% of my CPU's capabilities. So even though it's oodles more processing capability than an Arduino, you are still resource constrained. So that's why I think this is a good fit. All I needed to do is to start up the ROS node, rates I have everything set up at. I've got a pretty good balance. We're using 198 out of about 360 gigs of RAM. I haven't even hooked up the swap on this yet because it shouldn't be using it. Every time it boots up, it clears out the log files from the previous session. And if you ever want to get onto the robot, you don't have to even connect to it directly. Just connect to it by the access point, run an HHS session, and you can get into the system and make any changes that you want. It's set up like a standard ROS system. Let's see, is this easy, kind of easy to read or not? Is that not that hard? Let's see that.
Sort of washed out.
A little washed out?
If we want to turn the layout.
Let's see. Do you see it?
On the feed.
Okay, so here, let's try turning off the light and see if
You're not,
No, I would have done it.
here, let's see.
I will see it a little bit better.
the blue is hard.
All right,
You can turn off that.
Jen, can you jump the camera a little bit? It's coming off the top corner.
Up?
Yeah, just tip it a bit.
Okay.
okay, all right, thank you. So this is, once you get into it, and if you need to, this is a standard ROS system. So there's a standard Cat10 workspace directory. In that Cat10 workspace directory, there's a source directory. And in that source directory, there's a couple of supporting libraries that boot up automatically, but the most important one that you probably want to think with is the one called Todd. And in Todd, there's some directories for nodes and scripts. So if you wanted to use this to do something similar but with additional capabilities, or maybe you wanted to use this, but you're not going to use it on MU. Once you boot it up, log in through SSH, just disable. So I'll go to the launch file here. Launch file. And this is all Rossi, but you know, if you decided that maybe you wanted to run this, but you didn't want to run the camera mode, it's written in an XML type format. So if you just delete that node out, you're not running the camera mode anymore. And it'll keep that until you lose the card or it catches fire or something, and then you can make the same change to the next one when you burn another image. But you're actually not going to be spending very much time logging into the robot like this. Now, for a while now, I've been championing the possibility of doing ROS on Windows, and it will work. I've got it here somewhere, maybe not. And it will work up to a certain point. Here's one of the things I started to run into. So if you follow the instructions for ROS on Windows exactly, you will get a functioning ROS solution on Windows. You can run through the tutorials, you can create scripts and nodes and launch files, and everything just works. So last night, I wanted to try to get an additional part of the demo right, because there's lots of code available to run like the YOLO or the darknet, the TensorFlow type image classification things in ROS. And there's a handful of ROS nodes that do that. And on the Linux side, more or less all you have to do is download the code, plop it in the source code directory, hit compile, and you have access to that. Because that's one of the cool things about ROS. Once you use ROS and play by the ROS rules, you get to use all the toys in the ROS toolbox, including nodes people have done. One of the things that I ran into, though, was the code claimed that it was capable of being compiled on Windows, but it's not. So I'm going to continue working at it, but at some point I will probably switch back over to using Linux on the host side as well for this, but up to a certain point, up to like, let's call it level intermediate, you can absolutely just run the ROS spec on Windows. It communicates just fine. Once you set up the shortcuts for and through following the directions. Oh. And that is all done. Let me double check my nav here to make sure that so there are a few more things we have to do to get ROS working the way we want it to. So multi-machine ROS is built into the software stack. And earlier on, it was super handy because you needed more processing power than you can get out of one physical CPU. Well, now you can buy a 64-core 128-core CPU. It's probably less important. So the information is a little bit hidden. Basically, when you start this guy up, you need to tell it a little bit about how to find the ROS that's installed over there. So let's go ahead and find out what our IP address is. And off of that adapter, I'm 132. Okay, 132. We have to tell it how to find the master. This was all set up in a bash file, but I guess I didn't move it over to the laptop. 2, 168, 132.
So you're basically, the Windows ROS is usable up to a point, to intermediate level, and it's functional pretty well.
Yeah, and once you have the shortcut set up, and I'll show you my batch file that I use. I can just look there and see if we can go.
But there, it's not, yeah, the Windows is still kind of young or something, the Windows version.
Yeah, so you set up a bash file, and most of the instructions are on the internet. I just have to add in a few more lines to tell my ROS install that I'm going to be connecting to a remote master. And those 3 lines are to tell it what my local IP is and what local host name is. And that may sound weird, but that's because when you're talking between machines, there's no easy way to do name reconciliation. So if I call this, Alan's laptop, the ROS master over there may not be able to reconcile that. So I'll identify myself by IP address so there's no misunderstanding. And the third one is ROS master. This just gives it the address of where to find the master when things launch. So when IP 168.12.1 and then port 1131. You'll set this up in a bash file. And I think if I just run that, and you can set up your shortcut to run this automatically. I guess I didn't get to it before. All right, let's go over there. All right. So this is something you would only do once. So once you run those commands, this is not 25 specified. Let's see if we're connected. One of the first commands that you can run to interrogate a running system using ROS is to find out what nodes are running. So the command for that is ROS node list. All right. So as uneventful as that appears, what's that showing is that the ROS that's running on my desktop knows how to and has connected to the ROS appliance in Todd, has interrogated it for the list of running nodes, and has brought back the nodes that are running. So we've got a camera node, ROS out is for logging and debugging, the IMU live node, the servo node, the temperature node, and the ultrasonic node. You can do the same thing for topics. So what types of messages are being passed over? The command for that is ROS topic list. And after a second, you can see we've got a bunch of topics. The way the camera node works is that there are a bunch of camera topics to help control and get the different data from the camera. Command distance is command is for the servos, distance is for the ultrasonic. And then IMU is for your IMU frames, and then finally temperature. So again, we're running ROS here on the laptop, but because of the way we've configured it, we're using the Todd as an appliance, and it's actually driving more or less where it'll connect to it and talk to it. So at this point, anything that we write, ROS file on the laptop, will run on the laptop, but communicate with the robot. So they're kind of cheating. It's that brains are over here, the appliance is over there. So our hello world for this guy. So if you decided this is what you want to do today, and you download the image and pop it on your car and boot it up and then connect to it from the laptop, aside from running these simple diagnostic commands, you may want to start working with the messaging nodes a little bit. So one of our topics is temperature. One of the commands you can use to interrogate it, and this is all built into ROS, is info. So ROS topic info, and then type in temperature. And after a second, we can see that it passes a type of message called float 32. So it's just sending a number back and forth. And right now, there's only one person connected to that topic, and that is the publisher, my temperature node, the one we saw earlier. So let's find out a little bit more about it. Let's type in ROS node info, and it's a temperature node. All right, so here's the temperature node, the one that's running on the robot to give me periodic temperature. It publishes through debugging, through ROS out, and it also publishes through that temperature topic with the services we're not even using. And there's some more information and details about how it communicates. I'm not even sure on how to use that.
I'm sorry, ROS out I might have missed. Is that like for logging?
For debugging and logging.
Okay. Yep. So that's always that you kind of always want that.
It'll always be running, but you can choose what you log to it. There are certain system events that will always be logged. But just like in Python or computers, you may choose to put in debugging statements that log stuff out, either conditionally or all the time. And the ROS out and ROS logging is for the exact same thing. You can choose to pump it out to the log file or on screen. It's pretty flexible. All right, so we have a temperature node and we have a temperature topic. Let's find out a little bit more about the temperature topic. Let's find out about that message. ROS message, info. Standard messages. I think I got that right. Nope, okay. Oh, /. All right.
Does it tell you? Oh, it's right up there. Right? But you're just copying that.
Yeah, so it interrogates the message type. There are a whole bunch of standard messages, and when possible, you'll just want to use a standard message type. But it is so easy. Like if you're setting up two nodes and there's a certain frame of information that you want to pass in a certain format, it's constructed almost like if you've written YAML config files before, but you can structure out that data however you need it, and as long as both your sender and receiver has that message template, you can communicate just fine. So I did use some custom message types in Endu, but I haven't had to use those yet on Todd. So far, just using the standard ones. All right, so let's look at that topic again. ROS topic, info temperature. Let's find out a little bit more about it. So this is your hello world, really, when you want to try this out. If you want to know how many messages you're seeing a second, that's going to be a ROS topic hertz. And it'll subscribe. And it looks like I'm getting about 1 a second right now. One of the things that I want to do on the ROS core solution is to set up a property file where you can configure these things without going into the ROS. That will pull the property file and you'll say, oh, I want ultrasonic to fire off 10 times a second. So when the ROS stack boots up, it can look at the property file and take those settings in. I haven't done that yet, but that's next on my list.
So right now it's just doing it at 1 a second. I mean, is that as fast as it can go, or is it? Or is it? How does it know?
So I've written a node in Python that pulls the ultrasonic sensor. Right now, once a second.
Okay, you're polling.
Yeah, and it's actually a very good point because, and maybe I still don't know how to do it. I'm running it the same way you do an Arduino, is that you kick it off, you wait, you look for a return. Well, that waiting takes up time. So there's a real limit to how fast you can pull it based on the speed of sound, right? So you'll be able to run it like 1,000 times a second. You just won't be able to get
for the ultrasonic.
So I'm looking for a balance between how many times I hit it, how often I need to be updated, and how much it's hitting the computer. And I thought I had it set to more than 1 a second.
But that's the temperature.
This is temp, not audio.
Oh, I'm sorry.
You're
You're
talking
right.
about
Yeah, my bad.
ultrasonic.
I'm getting all scatterbrained here for a second. Sorry, temperature is 1 a second, yeah.
So
So we're well and good, but what is the temperature?
yeah, I know we haven't done.
You know what? I am so glad you asked.
That's the big builder.
Right? That's the highlight of the whole time. So let's do a ROS topic echo, and we'll give it the name of the topic.
That's Celsius.
That's in Celsius, yeah, civilized units.
That's pretty warm. Well, that's inside the.
Yeah.
It's inside, and the for the nerdier among us, the Raspberry Pi Zero is actually a stacked die with the CPU on bottom and the memory on top. So it really doesn't make much sense to add in a heat sink. It's very limited use, but it's designed to run up to 60 or 80 Celsius before these things get weird. I don't want to run it up to 80, but I feel okay between 40 and 60, and that's where it's
Right, this is supposed to be a temperature of the processor.
Of the die, yeah.
Of the die, not like, external temperature.
Yeah, for sure. And the last thing I'll show you before we wrap up, we started a little bit late, but you guys taking a couple minutes.
direction.
So let's do a ROS run. There's a node called image view. So package image view, program image view. Image is going to be, you can tell I typed this in once or twice, right? Camera, mode. What was it called? Camera node image raw. Okay. Cross run, image view, image view.
It's the mouse.
Yeah, I think that.
Looking at you then.
Camera node, image raw, image transport.
These are great candidates to put into aliases.
Oh, yeah,
Linux
for sure.
aliases, so you could just type, I would immediately make that Ross Von image.
And you can send a batch file, like, I typed it so much that,
I hate typing long things, as I do like many times, so. There you go, it is. There you are. That's what I thought. Oh, wow.
here, let's get, it didn't get the aspect ratio right. So it's running a low resolution image, we're still passing the CPU at about 50%. And so that's kind of the highlight of this ROS appliance, is that it'll run on its own, it'll boot up once you give it power, and once you connect to it through Windows or ROS, as long as you're talking to it in the ROS way, you can do all of your coding and all of your processing on your laptop or your desktop, and then just use your robot as kind of like an intelligent desktop development platform. So my next steps are to get the file in. Eventually, I will get it to walk. It's not that I can't or I won't. There's literally hundreds and thousands of quadrupeds out there, so because it's a solved problem, it's a little bit less interesting to me than some of the other stuff. This is a 2 degree of freedom, Todd. The one in orange on the desk is a 3 degree of freedom, Todd, with a little more advanced legs, more spider legs. The prototype works. I just have to scale it down to the final size, so it's halfway down. And the third one, the Spot Mini, I haven't started that yet, but I have some ideas on what it should look like, and it'll all use the same platform, just different leg orientation. And as much of the code base work I'm hoping to share as possible. Everything's available, open source, Thingiverse, GraphCAD, GitHub, and hopefully I'll have another FE for next month.
Now, is that his camera right now, understand?
Yeah, it's right from
Yeah. Yeah. Pass it around a little bit. And so you get all this for free. The camera is currently spinning out 320 by 200 images at I think 10 frames a second. But again, it's a balancing act between the processing power and the bandwidth you have and what you need. So with these settings, I think it's 10 updates a second for the ultrasonic, I think 20 updates a second on the IMU, 10 frames per second on the camera. I've got my CPU pegged at 50% with some extra bandwidth, and so if I want to add anything else onto it, it should be able to support it.
So the rate of those is, you're just saying how many per second, is that programmed on the robot side?
Yeah.
So when you query from, but you're talking about polling from the PC side, from the host, that's the host, right?
Yeah.
So you can, I guess, query faster than the thing produces, but you'll only get updates every time it produces an update.
Yeah,
But
exactly.
they can go at different rates.
Yeah, and that's a good place to wrap up on. So I threw a lot of terms at you guys, like asynchronous communication.
Oh, yeah.
And for some solutions, this is a real problem. You want some guarantees about when the packet was sent, when it'll be received, when it'll be processed. ROS 1 isn't like that, and that's why some projects have moved on to ROS 2 or custom frameworks and solutions. So you've got, going back to my document here. Nope, not that one. But it will come in handy. This guy right here is that, so you've got these two nodes that are talking. Oh, yeah, Jim.
You know, looking at your little robot, the module that appears to be glued to the top of the battery pack seems to have only 4 wires soldered to it, but it has many more contacts available.
Mm-hmm.
What's the reason for that?
So the 9650, I think, it can communicate over a couple of different ways. So I'm using the chip over I2C. So all I need is a power, RAM, data, and clock. If you're using SPI, there's different pins for SPI plus the select pin, I think.
Yeah, there's a master out, slave in, and there's, the other one goes the other way, I forget what it's called, and maybe a slave select?
Yeah. And then,
Okay, so, but you're using it, So you've got SBA and SCL, is what you're saying. Plus powdered power and ground.
Just for it. And a previous assessment was brought up that without the interrupt pin that they were very hard to use, and I was super worried. And I actually soldered in, you can see some solder glue where I preemptively soldered in an interrupt pin. With the RTIMU Lite and Lite 2, it's able to communicate effectively and efficiently with the IMU without an interrupt pin. I don't know how it does. It's a solid solution from my perspective, but I was able to get a fan out of it without using any more than 4 pins.
Now, the bottom cavity, which seems to have a bottom and a top section, what wall thickness did you use approximately?
Off the top of my head, I can get you the exact answer a little bit later,
Well,
but
I
I
don't
can't
know.
remember if I brought it down to
Like
1.5 millimeters or 2
quarter inch
millimeters.
Just a guess.
Yeah, it's probably 2 millimeters.
Ah, okay.
Probably.
And what plastic did you use?
So that was done in PETG. One of my
Oh,
goals for this
PETG,
project was to
yeah.
get some more experience running PETG projects. And so far, I love it. It's hard to paint, not very much will stick to it. But for a project this size, super glue worked just fine for final assembly.
Okay.
And it has more give than ABS, and it's a little bit more tolerant to drops. Now, funny sidebar, last night while I was working through this, I was thinking, oh my God, how funny would it be if I accidentally dropped them the night before my talk? And wouldn't you know, within 5 minutes, I kicked the power cord because he was plugged into a wall wart, pulled him off the table, fell onto the side, and broke a leg.
You broke a leg.
I am my own worst enemy.
Yeah, but they say break a leg, you know?
But some super glue in about 30 minutes and on a warm heat bed, and he is fixed good enough to use. So he's right on the line between fragile and delicate and just strong enough.
Yeah, but the PETG, is it a good combination of toughness and strength, or is it more strength but not very tough? Because I would think in terms of ability to absorb some energy and maybe just bend a little instead of snapping. Like steel, they claim, is an excellent, they claim is so good for things like iron because it bends a little and absorbing energy, which they call toughness. But strength, glass is a lot stronger in strength, like pounds per square inch before it shatters or breaks. But it won't absorb energy out of remaining bent, it just shatters.
Okay, and I think it's called ductility, right?
Well, yeah, ductility, that would be, is that the one where you can pull it through a die to make like a wire, or is that the one where you can pound it into shape? There's ductility and malleability, and they all
Yeah.
confuse the two. But
Uh,
either one means you can deform some.
yeah, so let's put them on a
But
spectrum.
putting it into
So
a wire,
yeah,
that requires a lot more ability to deform than, let's say, taking a bar of it and making it bend by hammering.
sure. So let's look at it. I don't know how to use the term strength to describe the plastics, but I'll just use the words I think about it with, which is
Tensile
bendability.
strength.
So
Like pull on a piece of it
Yeah.
harder and harder until it breaks.
yeah, so I'm going to put them on a spectrum. So we'll talk about PLA, ABS, and PETG.
Mhm.
Now, your interlayer adhesion is about 50% of the strength of the plastic itself. We all know this, right? That's why they're not as strong as injection molded parts. But there's, and I'm going to say, I'll just round up, and I'm going to say I believe they're all about the same strength, but they all have different amounts of bendiness before they break.
Oh,
So it depends if you want more rigidity or bendiness. PLA is the stiffest of the three materials, but that means up to its limits. If you go past it, it just tends to break. ABS is a little bit more bendy, so it's a little more tolerant of drops and falls. And PETG is even more tolerant of drops and bends, up to a limit. So when you're deciding on a plastic for a solution, you just want to decide if you want to favor a little bit extra bendiness or extra stiffness. And of course, if you want super stiff, you can do PLA with embedded carbon fiber tips,
oh,
which
you get
is
that.
super stiff. I should bring this in again. I printed
So
out.
it has embedded carbon.
Mhm. Yeah, I do these every once in a while. I printed out some Ducati brake handles
Uh-huh.
and all kinds of stuff. And nylon, but the print kept failing because I can't print nylon. ABS, PLA with PLA with carbon fiber embedded in it, PLA that was cured at a moderate temperature for 20 minutes, and PET G. And they're all the exact same shape, except for the nylon one, which is about half full. And you can feel, even when you flex them, which ones are better than others. But there's an even better test. I'll bring these in next month. It's a cool demo. You can just take each handle and tap it on the desk. And the tone of the wrap will tell you how.
Oh, it's like,
how
it's
stiff
like
the
looking at a
material
watermelon at the
is.
supermarket.
Exactly, yeah.
Oh, so what type of sound indicates what?
So a higher tone indicates a stiffer material.
Oh, I see. That's nice. You know, on my 3D printer, if I'm printing different materials, if there's any little runny pieces left over and it's ABS, if you bend it, it turns white. So that's how I can tell sometimes. Like if I'm printing something and it's a thin section and I wonder, when did I print this in? You just bend it sharply. Of course, if it's PLA, it's snap. But if it's ABS, right where it bends, it'll turn white. Have you ever, many years ago, there was something called a Dymo tape machine for making labels, and it had a flat roll of plastic tape. That was ABS. So where it gets bent sharply, which is where the letters form, turns white. That's why. Because it's ABS. That's a test for ABS. In case anybody who wants to know, that's a test for ABS.
Right
I was
on.
gonna say also, PLA, if it's gonna be outdoors in the sun, you obviously don't wanna use PLA, because that's subject
Yeah,
to,
it melts a little.
it
yeah,
it can warp and, it can become warp brittle.
And when I print
right?
nylon, which I hate to do, because I have to change the
That's
print
okay.
bed. You can test for nylon because it's sort of a self-lubricating plastic. It's pretty slippery stuff. Is it going this way?
So I'm sorry, your first point about injection molds don't have the layers, is that why, is that your point about, well, when we 3D print, you can always break the 3D print along the layer axis?
You actually have to take grain into account if you were gonna make something you cared about.
Yeah.
Right.
And it was a revelation that I think Eric brought up during one of his talks 2 years ago. And when you look about how 3D printing works, it does make sense. You have layers of melted plastic, and that the XY tension is going to be as good as injection molded because it literally is melted plastic there. But as you lay each layer on top of each other, the name of the game is you want your previous layer to be just warm enough, but not warm enough to be goopy. And you want your new layer that's laid down to be hot enough to lay it down to keep it shaped, but not so hot that it splatters or oozes, but still hot enough that it melts the top of the previous layer so that those polymers can intertwine a little bit. But even with all that, when it's perfect, your adhesion in between layers is only half of what it is for normal plastic. So you absolutely have to take that into account when you're designing something. The forces that are at play may suggest what orientation you want to print that part out based on what you're using it for. And that's the other reason why it makes finite element analysis so hard for 3D printed plastic parts. There's a couple of tools that claim to help approximate it, but when you have one solid lump of plastic, FEA analysis is straightforward, and there's FEA tools built into Fusion 360. But when you have to take into account the layers and the early adhesion and the fact that it's not solid, there's no tools that can accurately figure that out. Yeah, okay, sorry. I'm over, so that's all I've got. Thanks for your help.
All right.
Thank you.
I guess we're ready to read them.
All right, huh? We need you for next month.
I'm sorry.
We need you for next month. We need you for next month. Okay, so that was Alan, and now we are.
Okay, right where you were.
Boulder is going to give us a wonderful talk on the outreach for the club. And Alan. So we don't know.
Plugging into competition.
Yeah.
That's not what I wanted to do. Yeah, there we go. Okay.
Bob's on you.
Okay, Alan, could you work with the,
Bob's on you.
okay, Alan, could you work with the, here. Should be, this is a new projector, it should be much better to have.
Oh, that's a new one.
Oh, that's good. Well, they're not big enough. Oh, no, I was already plugged in, right? All right, let's see this.
Okay, we're having some technical difficulties with the projector, but we will solve this in hopefully. Oh, you know what? We might need to reboot this guy before he finds it.
So it's on HDMI too, but it's not saying anything.
Yeah.
Yeah.
Which one?
I wrote on there.
HDMI too? We used to do this for you.
Oh, that temperature was 120 degrees Fahrenheit.
Yeah. And then,
Which
is it
is
HDMI?
pretty hot.
Yeah.
Yeah, it's worth one thing.
Yeah, it goes up to about 50, I think, or 55 at the highest so far. But that's the other reason why I have it on there, is to check. In worst case scenario, I flip them so you can take on to 50
Right, yeah, that's what,
15-minute class.
possibly a
Oh, here, we have the other table.
right.
Oh, you know what? You have the VGA.
There you go.
Yeah, where'd it go? That's what I'm looking at.
We're at
There it is.
Okay.
Okay, if somebody could cut this first bank of lights right here. Okay, are we ready?
You're on, Bob.
Okay. Well, ladies and gentlemen, thank you for your patience. We've got a two-part presentation. My name is Bob Barbosa, and I'm one of your board members. And the first part of the presentation is going to be on design engineering and robotic design. The second part of the presentation is going to be an event we did at the Ontario International Airport. And I'm going to try to give you a sneak preview of that event to see if it's something that the club would be interested in exhibiting there. So we'll take a look at both of these. I'll be doing photo essays. So what I do is I work with students in the Long Beach Unified School District. There's a special group called the Mathematics Collaborative. And those are some of the top math students in the district. I work with them in the area of space science and design engineering as it relates to space science. So I'll give you a little sneak preview of what that looks like. If time permits, and it doesn't look like it will, we would show you some of the science experiments that we're doing with robots. So let's see. Here we go. So, my area of specialty is design engineering. And I'm an educator, design engineer, but I'm working in a special aviation and space program. And to give you a little example of that, last night I was teaching a class at Cabrillo High School,
and 8 of my students got a scholarship to go to the Ontario International Airport to get their pilot's license. So normally something like that would cost several thousands of dollars. It's a very expensive process. So I made it possible for those kids to get a fellowship so they could get that license for free. So we went into the inner city and found kids that would never be able to afford something like this. And we made all of that possible. So when they're with me, they study space science. When they're at the airport, they're working on their pilot's license. So that's my new project. We call it the Pathways Program. So here it is. I'm training junior astronauts, junior engineers, and junior scientists, and now pilots. This is our curriculum. NASA suggested that we add this piece, and I was thrilled that they did, the design piece. So normally we had STEM, science, technology, engineering, and mathematics. We fought with the Obama administration to get visual and performing arts in there. Visual made it first, and then we had to convince them that performing arts was the brother and sister act. And then we had to go back and work on computer languages because the study of computer languages is not mandatory in our school. If the school principal said, I don't want to do that, he wouldn't have to. So this is important for America and our future. And world languages. Look what the world is like today. I mean, because of the internet, we're talking to people all over the world constantly. So we now have to seriously go back into world languages and take that seriously. So, of course, my big thing is Mars and the designing of everything on Mars. And, of course, the safest thing is to send robots to Mars to handle as much as you possibly can, and then humans will follow. So I'm from the school of thought of robots first until you really get it together before we go up there and kill a lot of humans. So I took a page from the Russians. The Russians were working on a beautiful experiment, and I wanted to build a habitat inside of an airport hangar. So I have a 50,000 square foot hangar, and I want to build that inside of it. And I'm copying that from my good friends, the Russians. They sent a cosmonaut in training to study with me at USC, and she turned me on to all of that.
So you want to duplicate this full size in your
Yeah,
hangar?
yeah, and I'm looking for people to hire to help with that.
Okay.
Bob,
Yes,
now, in the design of this, these long tubular structures which have a number of partitions inside, was that modeled after some of the modules on the International Space Station, or was that an independent idea? Because they have a lot of tubular type
yes.
habitats, which are
Right.
modules on
Right.
the space station.
When you think of a rocket going into space and
Yeah.
you've got tubular type designs, everything kind of fits in there really nicely.
Oh, so these could conceivably be leftover
Right.
portions of rockets.
Part of the rocket body.
Right.
I see.
And so all of my projects, I work on NASA Tiger teams, and all those Tiger teams have 10 members. So this is a module set up for 10 people to live comfortably.
Could those internal partitions and some, but not all of the other internal parts, be pre-assembled in there?
Yes,
before
that's
the rocket is
that's
even
the
launched?
whole idea. That's the
So that as the
whole,
fuel or whatever
Yeah.
comes out, those parts would be left in there.
the whole idea is to get clever designers to do clever things so we can save on space and weight.
Yeah.
At least give you part of the payload. So.
So, yeah, so here's part of that. North Face has this beautiful tent to hold 10 people. This tent is fabulous. It's the finest tent in the world. I think it costs $50,000.
Wow, that's it. That's what
No, I got the figures. I think this is 10,000 because the other thing that we're working on is 50,000, which is this bigger thing here. So many of those tents can fit inside. So this is some of the thinking that's going on right now. But this is
Too bad.
on exhibit right now at the LA Art Museum. And I was there Friday, it was my turn to go do guard duty. I have today off so I can come and see you guys. Sunday's the last day of the show, and I'll be talking more about this.
You know, it looks,
I did
it
this
looks
for-
like a Volkswagen robot.
That's right. That's right. So,
I
what-
used to drive one of those. I drove as
Okay.
a Super Duty.
Maybe that's-
It was a Volkswagen for
maybe that's a part of what you used to drive.
Yeah.
So, in any event, I sent a crazy note into NASA and said, what if we took something from nature and let that go across the rocky terrain of Mars? And I got a response back so quick it scared me.
What they say.
Well, they said, we gotta learn more about this thinking that you're doing. What I didn't tell them is to make that really move, it would cost $120,000
Something that heavy, yes.
in addition, yeah, so.
That's not
Well,
much, that's not much
Mars is
money in
gonna
NASA terms.
Well, that's true.
That's a
true.
small
That's
pittance.
a small amount of money, but that's what it would take to get that thing completely up and running. So right now, it's an art piece.
You're thinking hydraulics?
Yeah, yeah. So
Seems
this
like
is Kristen Castro. I'm working with a few designers from Argentina. And I'll have a chance to go to Argentina. And students from Argentina came here to study with me at UC Riverside. So we're getting really, really creative people out of Argentina, especially in the area of going to junkyards and working with a special symmetry. Imagine you're going to the junkyard finding the parts. So you got to find a part over here that's going to match a part over here, and then of course to go ahead and do that paint job. That's the paint job of a Mercedes-Benz on there, and it's sitting on plexiglass. So here's what it looks like at the LA Art Museum. They gave us a nice spot in the middle of the floor, and it's on exhibit right now. So if you want to see it, between now and the end of the show on Sunday, it's there, and it's a wonderful exhibit. So here's a little inside closer look.
All over the United States.
Here's a little video. Now,
Here we are at the LA Art
I
Show.
gotta take my hat off to your engineering team. So I thought I'd walk you around this guy.
What you should have done, Bob, is put ahead of the video screen there showing what you were planning to do with the thing and how the thing was built and stuff.
Well, I have one more shot at it on Sunday. That's an
In the future,
excellent
you would
success.
be able to do it for this, but in the future.
Yeah. So I knew I was coming here and I knew you'd be interested, so I walked around the guy, kind of give you a look.
Go to this box cylinders and stuff.
Yeah, because we have an aviation junkyard, we're able to go there and get extraordinary parts.
I can imagine.
So you just wander around the junkyard and you have to say,
What's inside the body, anything in
well, I
there?
want to put all the science experiments inside the
No,
heart.
inside the body now, what's inside?
It's hollow, with just enough
You know, what
electricity
you
for some
could
light.
do is have this thing actually talk about itself.
Oh, yeah. Well, that's why I'm doing this presentation. Take a look at the rest of this stuff here. Okay, so I'm walking you around, trying to give you the best look. Pretty good photography.
What is that round thing anyway? What is it?
Little aviation parts that we found, random
Okay.
parts here and there.
The repurposing is for something they're never
Right.
meant to do, okay.
And you'll see why in a couple of minutes. So we went through, did all of this. We knew we had to get it for the art show, so we got the green light at the art show, and of course, I'm always recruiting young astronauts. This guy was incredible. He got all dressed up to do this thing and showed up. I have no idea who he is. But this is my crew from the high school. So these are all my high school students. But this young lady is Alyssa Carlson. She's 18 years old, and she's the youngest female astronaut in training. And she performed after the halftime show at the Super Bowl. So there was that special commercial where there were 3 astronauts. She was one of the 3. So this was a couple of days before the Super Bowl. So,
Is that segment available to look at on the internet?
yes. So here we go, and then these are the robots for next year. So same thing, going to the junkyard, finding the different parts, doing the world's greatest paint job, and then getting them ready for exhibit. And these are the robots that I'm planning for next year. This is part of a collection of the robots that would work inside of a building on Mars, and the robots that would work on the outside of it on Mars. So it's divided
They would
up.
get along well with the Martians, who also have the long fingers.
That's right, that's right.
No one's 3D modeled these things yet, have they?
No, not yet. So I went from these conceptual drawings, and now the dream is to have all of these robots designed just like the crab on exhibit with a special musical performance to go along with all of this. That's what I'm preparing for next year's LA Art Show, would be building these robots. So here are the different designs. Give you an idea. Indoors, outdoors, multiple views, all kinds of different concepts.
Awesome.
Yep. Remember this? This is for going long distances indoors.
Okay, so it's like space
It looks like Buzz Lightyear a little bit.
A little bit.
The head does, yeah.
And the body,
Yeah.
stature.
Little something to trigger your imagination.
Could you back up one?
Sure.
That one really triggered my imagination.
Right there.
So it's sort of two arms and it's sort of four arms. A combination arm.
This is meant to do a series of science experiments on the inside of the shuttle.
Do you have a bunch of, do you draw these, or do you
Yeah.
have, these are all yours?
Yeah.
That's the design part. Cool.
Yeah, these are.
Ooh.
And then on the Are We Alone in the Universe series, I really want to have fun making robotic aliens. And I have a collection of, I've got a collection of 10 aliens, and this is kind of an example of
Is that
putting
your
together
art
an educational science fiction scenario, Are We Alone in the Universe? Yeah.
Did you yourself produce any of these sketches?
Yes.
Well, you are doing an excellent job. I wish I could sketch that. When I sketch something, it looks like something that was drawn by an engineer. Guess why?
Well,
I am.
There's a team of about 4 artists, and they all work together like a team, because this is a tremendous amount of work.
Yeah.
Especially when we move it to the next stage of mechanical drawings,
Yeah.
so you can build from. So here's an idea. Well, I was talking with Walter. Walter and I, Walter was kind enough to appear in a few of my musical performances, and now we're working on a concept called the first robotic band on Mars. And these would be the instruments that the robots would play. So I'll give you a series of these. This is some work that I finished last year.
Just imagine Olga's cantina.
Well, it would be hard to actually physically build
That's an
it.
engineering tattoo. I love that paper.
So with a bunch of sensors, we could have a wall making these kinds of instruments, and especially performing. Imagine being the first robotic society of Southern California that performed in an orchestra made up of all of these instruments. There you go. Lots of concepts, lots of ideas.
Oh, no, there's.
And then,
That's an actual.
when the art community takes a close look at this and says, okay, what if we did start to build this stuff out of metal? what would those designs start to look like? So where's my good friend that's into railroads and road?
He's the model.
There he is, yeah. So, you were the one that talked me into all this railroad stuff, remember? And so, that was on the mind, and,
Is that an actual thing?
yeah, that's an actual saxophone, and those are actual parts, yeah,
Runs on steam.
yeah,
This is steampunk.
yeah.
I've
And then,
seen something
Walter,
like that.
That's
When-
the first Harley
when I
Davidson.
first got into robots, Walter would bring his motorcycle over to my house, and we would take the Now robot and take these beautiful pictures with the Now robot on Walter's motorcycle. And around that period of time, this kind of thinking was going on. And this is some of the design work we're doing for the Mars project, and my good friend right here, our good friend right here from the club, used this 3D printer to make a sun locator. And I needed to know where the sun is. Oh, I better get the camera here. I'm walking around like we're not on TV anymore. What happened with this particular design was I needed a way to find the sun during a Martian windstorm. And so,
I'm glad it all worked out.
yeah, so it worked out perfectly. How long did it take you to make that for me?
Oh, I don't remember. It took about a week to get all the parts, I think.
Yeah, so about a week, I gave him the specifications, and he came up with the design, and it's been working perfectly. It finds the sun every time.
You want more, I can make more.
Good. So here's the deal. We can grow food on Mars. And we can simulate what we need on Earth. And I taught that class last night. I taught a class where we used a special robotic growing device, and we used all of these micronutrients. We had them all planned out in containers, and the kids went to put it all together. They've got the seeds and everything. They're taking everything home, and then they'll send me pictures of the growth of the plants.
So you make the soil up and treat it with all that stuff, and they're actually growing stuff in
Right.
it?
We have to keep the pH level between 6 and 7, constantly upgrade the nutrients, and then everything works great.
Oh,
And we're starting to get production like this. My wife, every evening, she goes out and gets a little salad for the table. So, and I can't believe how fast, I keep saying, oh, stop cutting, stop cutting. I think she's gonna, bring these down to a 0 level, but I can't believe how
So
fast they keep popping
This
out.
is like some sort of hydroponic.
Yeah, this is a hydroponic setup.
Oh, that's pretty cool.
And I can thank our wonderful treasurer there for giving me some beautiful hot tips on electronics. And now we're working with different light sources to make that happen. And then it becomes a matter of childcare. Every once in a while on Wednesdays, I have to watch my son's son. And so it's nice to be able to have these robots to be able to help me with childcare. Let's see if we got one that runs. Yeah, here we go.
Interesting reuse of outboard motor stuff.
Yeah, well, this is the Latin American Museum, and it's a special collection. And as far as the child care is concerned, it's perfect. So if you ever have to do child care and you need robots to help you out, this is it. Just give me a call. This thing works perfect. So I consider this robotic because we have a serious situation with gravity. And you're on these long 8-month trips going to Mars. And we have to deal with the gravity situation as you're going along on your trip. So that means we have to have this constant rotation so we can create this artificial gravity to try to mimic what's happening here, because it affects everything. It affects the growing of the plants, the cells in your body. It's just traumatic. So a lot of the new designs for anything going into outer space is also coming along with gravity chambers. Question in the back.
In terms of growing plants on Mars, I've always kind of wondered, like, how much do we actually know what the composition of the soil is to the extent
Yeah.
that, like, could we just add nutrients and it would work? We just plant stuff around.
Down and get a handful of soil, you would be lifting Mars regularly, right in the palm of your hand. Mars has all the nutrients that we need and micronutrients to grow whatever we need.
Just need water.
That's right.
Water.
Water is the key.
Water,
So the
oxygen.
big thing on Mars is we know there's ice. We know we can melt the ice to get some water, but we haven't found liquid flowing water yet. That's how come the new probes on Mars are going under the surface. So we're thinking if Mars has active volcanoes, that could produce enough heat so liquid water would be found and be possible. If we can find liquid water, we think we can find life. But without liquid water, it's bad news. So we have a moon called Europa. 26 miles under the ice on the moon Europa, we have liquid flowing water right now. We think we might find life on the moon Europa first. No, that's, no. It's the moon, Jupiter's moon. Okay, here we are with the humanoid robots. One of the things I'm doing right now with humanoid robots is having them work on science experiments. So we've got some work going on with that, and of course Pepper is here. Well, this red one and Pepper are right here at Cal State Long Beach. So Walter has those robots. And the robot world is making a tremendous amount of progress with Pepper right now because a lot of people are concentrating on that. And it can do much more. Pepper sells for about $30,000, and these other robots sell for about $10,000. So when I started out in the robot world, I started out with the Now robot. And we can do a lot of things with the Now robots, especially with the dexterity with the fingers, and that's how come I'm able to do science experiments now. So this is a special pH probe, and Now is able to, with its 3 fingers, hold that probe and place it where it needs to be placed. It's absolutely amazing. So here's a lot of the work that I'm doing right now is getting plants ready, seeing how fast we can get seeds to germinate and all of that kind of stuff, and then work with robots to monitor. And I can't believe he brought it, one day he dropped it off in front of my house, it was like this, and now this thing is gigantic.
Yeah, they grow pretty fast.
Yep. So one day I have to come in here with the Doobot robots and show you what I've done with that so far.
Greetings, everyone, and welcome to the Barbosa Space Center. This is a little experiment that we're doing.
We're trying to get
because we're
different
working with
robots to
robotic
work with
arms,
each other.
and we're trying to
Here's an
teach our
example.
students how to operate these robotic arms, and then be able to come over to the computer and set all of the special parameters so the robotic arm can do specialty type projects. So one of the projects that we're doing today is we have a rolling robot, and we would like the suction cup on the robotic arm that you can see the suction cup right there in the middle. That suction cup is going to be able to pick up a little piece of cargo. And if we can get the cargo underneath that suction cup, when it's down here on the table, of course, we want us to pick this cargo up and, of course, place it on the robot. So this gets a little tricky when you're the cameraman and the robotic arm operator and all of these people all in one, but we're going to try to pull this off.
So
the
we're
first
able to
thing
set
we're
all
gonna
the
do is
parameters,
come
as you
here.
can see, and do a wide variety of experiments.
Do that. There we go. Now, there looking for cargo, see if I get lucky this time. No, that's done.
So,
we got
the long and the short is, you can set all the parameters, you can put everything on autopilot, and the robot will work all day long doing the job.
Exact location.
Okay? So here it is, our plant projects, and that takes care of that. And now I'm gonna switch over to here. And I'm gonna switch to the next one, which is right here. And then we got go here. So, imagine coming with me to the Ontario International Airport. They gave me a 50,000 square foot hangar and said, you can turn this into Mars or do whatever you want to do with it. So we said, okay, let's start off by having a conference or a showcase. Let's just do something in there where we get a lot of people in the community into this empty hangar. So when I first stepped into the 50,000 square foot hangar, I never believed you could do anything in there. It was just too massive. So thank God there were other designers that had a little more creativity than me with massive space, and they started working on different things. So we were working on in the administrative office at the airport, and right next door was our 50,000 square foot hangar. So if you come to visit me, you would look for this sign, and you know how to find me. You go right through those doors right there and take a right-hand turn. So this is some of the people there at the airport. Here I am in the administrative office. I can't dress like when I'm here at the club. I got to step it up a little. And so here we are, and we've got the inside of the hangar is all set up for a beautiful classroom. So if we ever did something as a club, and I invited the whole club down there, that's where we would meet. So then, the room can be configured into all kinds of different things. Right now, the aviation program is going on right here, right now. This is my 50,000 square foot hangar. You can eat off the floor. I can't believe how clean that floor is in this place. So it's a lot of space to do something. So that gives you an example. The bathrooms are fabulous. The men's and women's bathrooms are just fantastic, and they were enough for us to do an event where I think we had 500, 600, 700 people at the event. So here it is when I take a different view. All of the doors open up in the front and back. So this is the space that I had to work with, right there. So I sent the person out there to kind of give you an idea just how big it is, how high the ceilings are. And then we have plenty of electricity to do all kinds of things because during World War II, they were making airplane engines at this facility. And so there was along the wall, no problem with electricity. So if we were to do a conference inside of the hangar, we've got electricity to burn. And then air conditioning, I had to check that out before we go down there because once we were in East LA, we didn't have air conditioning. And Thomas from Riverside said he's never coming back. So I said, okay. And he's from Riverside. So I said, okay, we got to make sure the air conditioning is where it needs to be, and it is. And then these turnstiles to help with the crowd flow. And this pilot right here in the middle is the person who's training in aviation right now. He's training my student. And he was a prisoner of war with John McCain. So when John McCain was shot down, he was, right around that period of time. And he's a very soft-spoken but wonderful guy. But when they told me that, he was in that prison camp with John McCain, that was unbelievable. So, Tony Marshall is his name. Wonderful person, wonderful pilot instructor. And then this is Jim Primrose. Jim Primrose came to us from UC Riverside, And he was the one that made it possible for me to teach those students from our team.
What's he teach at ECU or something?
He's in charge, he was in charge of all of the administrative comings and goings, especially international students.
Oh, that's awesome.
So I got a nice new uniform out of this deal, which was great,
That's cool.
but I'm actually paranoid of flying in planes. Absolutely. Because when I was in Vietnam, I must have been in about 3 crashes.
Yeah. Helicopter?
Yeah, so I don't fly for fun.
There was a helicopter?
Yes, all helicopters, yeah, yeah. So here we are, that's the facility. Who knows who this person is?
No idea.
When JFK was alive, he wanted to pick the first African-American astronaut to go to the moon. So this person is Ed Dwight. He's the person that JFK chose.
I saw a show with him. Yeah,
I remember the story about.
So you saw the show
the
about
Apollo,
Right.
during the last year, all the Apollo movies,
Right.
there was footage of him.
So
Right, but he didn't make it.
And they had his name was confused with this other, with Ed White.
that's right.
That
So
was the big
If
thing.
you get a chance,
Ed
look
White
this
was-
guy up on the internet. Look for any of his YouTube videos. They're making a movie of this guy. And I can see why they're making a movie. Remember that movie called Hidden Figures?
Yeah.
Did any of you see that?
Oh, no.
Well, he was around and he actually knows those women in the Hidden Figures things because there were just a few African Americans working at that level at that time. This would have been the first person on the moon if JFK was not assassinated. His story is mesmerizing.
Yeah, it's too bad he didn't actually be able to fly.
He didn't get to fly, right?
Well, he was trained as a jet pilot, a test
I
pilot.
mean,
He had the right size. See how he's shorter than I was? They were looking for guys. He reported right to Chuck Yeager. So Chuck Yeager, the story of him and Chuck Yeager, that's a whole nother
Yeah,
workshop.
I've heard stuff.
Oh,
Yeah,
unbelievable story. So I get to work with this guy, and his stories are just amazing.
He probably could tell us some interesting things about NASA.
Oh,
I
yeah.
bet.
Yeah,
There's a
this
lot of
guy,
stories.
he's really something else. So here's for a guy that doesn't like to fly,
We've got 2 airplanes in there.
there's quite a few beautiful, beautiful airplanes.
Well, somebody gave you a rocket engine, jet engine for your
Yeah.
birthday.
That's right. And there it is. Boy, it was your time.
Nice birthday present.
That was my birthday present.
You gonna try to make it run?
Oh, no, it's impossible.
Don't worry.
It's impossible.
It's old.
No, it's one of the old
Scrap.
scrap engines, God knows what could be wrong with it, but they're gonna try to turn it into something really beautiful. And this is the guy whose job it is to turn it into something beautiful. We all met when they were working with electronic buses in Downey. They were taking out the engines of old buses and converting them into electronic buses. That's where all these tools came from. So our students get these wings. Once they graduate, it's 18-week course. And this was the event. I was in charge of everything that had to do with space, and my counterpart was in charge of everything that had to do with aviation. So the 2 of us working together with our students, went down there. Kids were building computers from scratch.
That's a cool kid.
Yeah.
Is that a Raspberry Pi in there?
Yeah, Raspberry Pi and Linux operating system, and you're up and running. Do you see the hangar over to the right? That's my actual hangar. And the building straight ahead, well, this building is the administrative building, and then right next door is the hangar where this event took place. And here we go, plenty of parking. I got parking to burn.
Oh, gee.
And so here we are, trying to set this up, trying to turn it into, you guys have been with me to the robot showcase. You could imagine this. Look at the chair.
On steroids.
So we had to deliver the robot and get a forklift to lift it off the truck. And this is how we break it down into parts to transport this thing. You had to plan the case at the same time you were planning the parts because you had to, am I blocking you?
No.
Okay. So this is what it's like when you're planning your box for everything to come in. Takes at least 2 people to assemble it. You can't do it all by yourself. So here are the 2 people. It took them maybe 3 hours. And this is the little corner that I'm setting up.
Monster stage.
So what we did is we had 3 big screens in the front, a lot of people. And now the trick is, you guys have all done events with me for several years. And I'm having trouble filling the VA hospital. You could imagine how nervous I was filling a 50,000 square foot hangar. So let's see what happens.
Looks like you rented all the audio equipment and everything.
Yeah. So all of the trucks and everything had to come in the door and everybody had to be on schedule. Get all the parts ready. When you're taking robots on the road, it's a workout. So there it is. It's starting to take shape. Now the AV guys are coming in. And ClearTouch is an organization that does distance learning. So they have all cool equipment so you can do stuff like we're doing right now. So here, and then the drone people needed to put a tent up so you could fly the little drones inside of the tent. So here we are. You can see all of those drawings that I showed you were all along the way. And we had 3 people from this club show up there. One was our youngest member. You know that guy, what is he? He's in the second grade or something. He showed up. We gave him a booth. And then one other member.
I wish I could have been there.
Yeah, this would have been a nice event for this particular club, but I'm showing you now, so when we plan the next one.
Hey, Bob, in 2000, there was a guy who mechanized a robot that looked like that, called Mechadon.
Oh,
Then
really?
you search BattleBot, Mechadon. It's about that size, and it's got 6 legs like that, and it actually moves and it fought other robots in the ring.
Oh, my God.
Yeah,
Yeah.
it's huge like that, giant linear actuator from satellite dishes.
Yeah, I'll have to check that out.
Oh, yeah,
my
it
God.
moves perfectly, yeah.
Yeah.
So somebody already.
So there it is. So Walter says there's a guy that actually built one of these that moved.
Yep.
We
I
did.
actually fought in a ring, other robots.
Oh, my God. Good luck to the other robots.
Yeah.
So, and then this guy showed up. This is the latest and greatest in airport fire equipment, some of the best in the world. And we thought it was a spaceship when it pulled up, but there it is.
Oh, gee.
This is a killer machine. There's our students arriving from Long Beach.
So what's the little, that's the little
That's the
Raspberry Pi
Yeah,
project?
that's right. So they spent 2 weeks building a computer from scratch and then doing their mathematics with the computer. And then they're doing science with the computer now.
How did they like it?
They loved it. They absolutely loved it. And I loved it. I built the first one myself. That was a fun experience.
Sounds like it would be fun, but
5 of the California superpower companies, they're all working together on something that's classified, of course. And,
SpaceX is gonna launch something to the International Space Station
yeah.
within the next week.
Yeah,
Within the next
yeah.
week.
Bob, what was his name again?
Cal State Long Beach, and he lost his life out here in one of those ski boat accidents right here, right off of the campus. And one of the saddest things is when he came to visit me, and we had to come here to the campus and walk around, and he told me the story.
Oh, that's,
Yeah. So this is the young lady that was in the Super Bowl, and her name is Carson. You might want to look her up on the internet. She did a TED Talk that's out of this world. And since she's been 3 years old, she wanted to be an astronaut. So I got to meet her. I had an opportunity to speak in Washington, D.C., and she was the co-presenter. So I guess she was 16 then. And she gave an incredible, she's 18 now and going to college. They just dropped her off in college right after the Super Bowl. So she's a freshman in college.
where's she going?
There's a special college in Florida that deals with technology at a high level. It's called Florida Tech or something like that. I believe that's the college. So, and here's our crew, and she's in the middle, and these are different team members, different students, and then here are all of the pilots on the aviation side. And what's happening here is some of the kids get to study with people that are actually flying the commercial airlines right now. So these are two captains.
So do they get to actually go up in a commercial airline? Or plane?
For this particular show, we weren't able to take people off. I think something happened security-wise 2 days before or something, but the actual going up in the air portion of this thing got canceled. This is an incredible person. He's one of our chief engineers on the International Space Station. And one day, he gave me a book. And I said, oh, what's this? He says, this is a special project that we were working on. The book cost $1 million, and it's a robot that repairs other robots. So I have this book. I should bring it to the club one day, let you guys flip through it.
What's
It's
it for?
amazing. Well, it's I guess it was a project for Northrop Grumman that they were going to do, and they get so many projects, some projects, they just say, no, we're not doing this one.
So it was a robot?
Yeah, it was a robot that would go up into space and repair other robots. That's what the whole book is
Oh,
about.
that's interesting.
So the interesting thing was how you write up a book like that to turn into a company when the project is $2 billion or whatever it is.
That's probably a whole procedure in itself, I would think.
So his name is Michael Drasden. He's now retired, and he's a consultant with us. And so whenever we talk about anything that has to do with the International Space Station, he just mesmerizes you in your seat. I should get him to come here and talk to the club sometime.
Well, one of my instructors in college worked on the space shuttle cargo bay doors and how they opened and closed and were able to,
Oh, yeah. Yeah.
you know, run power off it and stuff like that.
So that is our prize in the sky right now. So talking about the audience, we were able to advertise properly, and we got a pretty good showing.
How many people showed up?
We think that it was about 500. Yeah.
Well, that's a big draw.
Yeah. Because we put out 500 seats, so you can see we covered that. We were able to get donations for breakfast and lunch. And the breakfast and lunch was fabulous. The only mistake I made was not setting up the booth quick enough and running over there to get something. I won't make that mistake the next time. So we had all kinds of people there. That's Dr. Felton Williams. He's the president of the school board for the Long Beach Unified School District. He was the master of ceremonies.
Oh, that's cool.
We had the color guard there. And here's all the different people in the audience. There's the students. You can see that the decorator gave us all kinds of different kinds of tables that we could do different kinds of things with. And so here are all the people, the beginning of this, the flag salute and all this and that. Who has ever heard of what do they call this thing? They called it a step and repeat.
Yes,
You've heard that term
I
before?
heard that term.
I've never heard that term before this. So this is how it works. We get our club's logo if we're going to be at this thing, and our logo ends up showing up like here. There's my logo. So let's say this was the club's logo right there. Then your logo would go on the step and repeat, and all these different dignitaries could get their photographs taken in front of this. Like if you wanted to get a picture with a pilot or a picture with a designer or an engineer or roboticist or whatever, you would stand in front of this thing. This guy owned the hangar next door where all of the real expensive planes were. And I guess we're going to go there any second. So here's the food. So the food was provided. I think this is lunchtime stuff, or about that. All the drinks were provided. And I made the mistake of, this is my favorite in the whole wide world, is the blueberry Danish. So I fooled around setting up robots and I got hurt real bad on the blueberry Danish part of things.
They were all gone.
Yeah, they were all gone. It's not worse than a robot guy when the Danish is going. Nothing worse than that. So, here is Alyssa with her dad. Her dad made it possible for her to do all kinds of things, Nike commercials, everything. But to hear her speak, that's worth going to listen to her TED Talk. Alyssa Carson. When you hear her speak, you say, she's 18? So here are, these are the people, young women were doing the drones. They had a special exhibit, flying drones inside of that tank. Here are the women on the drone project.
You got enough room in that hangar to fly them inside the hangar.
That's right, that's right. And so I felt safe the whole time because the police were right there with us, and the FBI, and the transport security. I never felt so safe in my life. Yeah, me too.
Well, they probably go all armed too.
Are they there for like for recruiting purposes?
Yeah, oh yeah, recruiting, big time recruiting. And here they are. I was talking about the two people that went to the show, and here they are, they just walked in the door. They were representing your club at this event. So here we are.
Agents.
There were all kinds of attractions. Okay. And that's it.
There's the next speaker.
Okay, I'm gonna go quick. So what I would recommend is work on your different projects. I've got the space. There's no charge for any of this stuff. And with the proper advertising, these events can be a success. So with that, I'd like to thank you for having me.
Did you play the video that I sent, or did you get it?
Yeah, you know, that video almost made it in time. So what happened is, under normal conditions, I would have loaded your video right here and I'd be ready to go. But they had me turn everything over to AV.
Oh, early,
Yeah,
like the day before.
and that's why I couldn't do it, yeah.
Well, at least they had a professional AV.
But it was a great video and I received it and he done it, yeah.
Okay, so yeah, sorry, I could have
Yeah.
done it.
So he made a video of the club that I could show during my presentation when, I think.
And we've improved on that now, with Alan's help, so we have a final version.
Oh,
I'll
then-
play it today.
Yeah, why don't you, send me a copy of that and I'll include it for the next. So here is your HDMI.
All right, so
Aside.
that concludes the presentations. We will resume the live stream for the show and tell. Like and subscribe. And this is going to be this morning session.